Welcome back, everyone, to Delta Y. This week we'll be talking about
new graphene-based wearables for health monitoring, food inspection, and night vision.
and an ultra-lightweight ceramic material that withstands extreme temperatures that could be used in space. As always, I'm Josh.
This is Grayson, and welcome to Delta Y. Alright, so the first article we're going to be talking about today is the graphene-based wearables. So, scientists have recently developed new graphene-based prototypes. Among the aims for these technologies is to turn mobile phones into life-saving devices. This comes to us from Graphene Flagship. So, a company called ICFO has recently put on a couple of their devices on display, which will allow customers to monitor their level of UV exposure from a graphene or a type of UV sensor made from graphene. It's designed as a flexible, transparent, and disposable patch that connects to a mobile device and alerts the user once he or she has reached a defined threshold of sun exposure.
And this is also interesting because it's talking about, other uses for this. So it's not just sun exposure it's saying also it could be used to, detect hydration or dehydration in certain cases, where their example was someone in the jungle or in the desert who could have limited water to track, the amount of hydration in their skin, actually. To see, are you dehydrated? Do you really need that drink? Or is it just a placebo in your mind that's going, hey, I'm thirsty, when really they're not?
Interesting. Yeah. Among the other uses for it, it can also be used with highly specialized laboratories for the detection of counterfeit drugs and harmful substances within a product that we could eat or consume.
And this is really interesting because it's, it's just they're using a phone to read this. So it's the graphene is, their idea is that it's a phone app that they simply scan this patch with a phone app and it would read these back to it. So I'm not even sure how they would work that, but apparently it's some sort of way in which our eyes can't perceive information being sent. But the graphene patch would be able to relay information via a UV, essentially I think it's what it's saying is the patch will react differently to things, and that reaction shows a different spectrum or something, and that's what they're using.
Yeah, the patch itself kind of looks like a Nicoderm CQ patch, or the kind of patches that people use to help quit smoking, except it's got an interesting pattern on it. I can only assume that pattern is with graphene. I don't actually see a chip or any kind of... I don't know if this is just the photo of it, but I can't see a chip. I can't see any antennas on there. I don't know quite exactly how it would connect to the phone, but...
Well, looking at it like this, I could see you scanning it, and you have information. So, each graphene stem that our picture shows would be, possibly... Oh, let's say it's, instead of being just a patch, each stem represents some information. So, one would change somehow if you were dehydrated.
So, instead of acting like an antenna that connects to the phone, it uses it like a photodetector, and it scans the spectrogram within a visible range of the patch itself, and then it'd say, well, okay, I think that actually says that later in the article, actually.
Yeah, and it's it's talking about how... I don't even know how this is possible. This is honestly incredible to me. Where, you could... This is incredible how thin this is. Because they're saying, this is just a patch. It's the thickness of, a sticker. But it's able to act as a sensor. And, connect to your phone. And, connect and display information about your body. And they were talking about this later in the article, and I saw that they're building it into a smartphone camera, and the graphene-based sensor would allow phones to see more than what's visible to the human eye, and that they would be made up of hundreds of thousands of photodetectors.
That's what I meant by photodetectors.
Yes.
Yeah, that's where I got that later in the article. I messed up on that bit.
Yeah, but that's we'd obviously have to have. It's not just a standard camera. We were mistaken there. It is a special camera that they're using for this. But still, the idea that they are already at the point where they believe that they can fit that kind of a camera into a phone, just a standard smartphone, which is a centimeter thick, less than a centimeter thick. is awesome.
Yeah, that's actually pretty insane. As with that, if you expand the range of the visible spectrum that a camera can actually read, it actually says in the article itself that it can be used for night vision, technically speaking, because it would be able to reflect off. It would be able to visibly see, or the camera would be able to quote unquote see infrared and UV radiation reflecting off of the graphene or wherever the spectrum it's able to reflect off of, and the camera would be able to see that. If you either coat a person with, or at least mark a person with that kind of a material, it would be able to process the information from that radiation, and you'd be able to see in the dark, essentially.
That's so cool. I mean, this is gonna be interesting to see, like, you know, how long will this take? And the biggest trick here, I think, is will we be seeing, you know, smartphone manufacturers implement this kind of technology in their phones willingly, or is it gonna take time? You know, even OLED today is just so expensive that some manufacturers aren't looking to implement it. They're sticking with LCD because it is much cheaper to produce, but the benefits of it aren't as great.
Yeah, true. I thought they had AMOLED as well. Like, in addition to OLED, they have AMOLED displays.
Yeah, I don't...
Power saving.
Yeah, AMOLED or power saving. I need to look up the difference more and all the different types of displays that exist, because there's LCD, LED, AMOLED, and OLED, and there's more than that even. Yeah. Like, I'm so far behind on what displays I know. I literally sit and stare at LED screens all day. Like, that, and I should say that my phone is OLED. But I mean, I need to look up AMOLED.
Yeah.
Because those are interesting.
Because I think Samsung, like their S5 actually had an AMOLED display.
So it'd be older.
It'd be, yeah, it's actually an older display, but it's still power saving. Like the black, like when you see black.
The blacks are black enough.
Well, no, they're not black enough. They actually just turn off.
That's smart.
They actually just turn off that unit of the display.
Yeah. But back on track here, I think that, you know, this kind of technology be hugely important in, you know, all sorts of different... I could see this being used in, you know, if we get longer range sensors that could pick this up, I could see this being implemented in, you know, supports and stuff.
Mm-hmm.
Just, like, you could put this on, like, a football player or, like, an Olympic athlete and just kind of monitor their vitals to see, you know, is something going wrong or not. Like, that's just so cool to me.
Yeah, I'm basically wondering how, what exactly this patch is constructed, whether it's pure graphene or if there's some mixture of other, I guess, chemical compounds in there as well that react with the graphene electrically to give it a different response with the spectrogram from where it's reflecting off of light and where the camera itself is able to detect all that.
And I think another concern there would be durability. You know, how long is it going to last? Like, is it a...
It looks like a patch. I don't really expect it to last that long.
Yeah, and I think that they would be shooting, I think, for, you know, a little bit longer of use maybe. Mm-hmm. But they could be so cheap to produce in the end that you could, like, put it on, measure your vitals, and take it off. Yeah. I think that's kind of their goal. But it's hard to say, and I think that, you know, for now it's kind of a waiting game. And speaking of durability, our next topic is going to be ultra-lightweight ceramic materials that can also withstand extreme temperatures. So this is out of the University of California, LA, UCLA, and researchers there have created an extremely light and super durable ceramic aerogel. So in the past, we've used ceramics and ceramic aerogels for insulation in the space industry since the 90s, really. You know, all the Mars rovers have it on there. But this newer version is much more, you know, durable. It's much better in high heat because it is a ceramic.
Mm-hmm.
So this is interesting that the material, instead of expanding when it gets heated, it actually contracts. So the way they describe it is like you take a tennis ball and you push that tennis ball onto a table. Normally the inside would bow out. Well, this would actually bow the inside in. So you'd be compressing in two directions, essentially. It doesn't compress and
so it compresses downward like gravity, but sideways kind of like when you're in water with pressure inside water.
Exactly. It acts like it has pressure on it.
Interesting. So like what is it? It
crumples kind of, and it can be, you know, compressed to 5% of its original volume.
To what? Like
you can literally compress it to 5% of its original volume.
Well, I mean, it's an aerogel. I'm surprised. Well,
it's a ceramic aerogel. That's the impressive part.
What makes it ceramic? I'm actually not that quite
So it's ceramically based. So it uses ceramic materials that, because ceramic is very brittle, right? Mm-hmm. It's like a dinner plate. But these are ceramic materials that are built into they're in an aerogel type pattern, I believe. Mm-hmm. And they're relatively brittle, but they're really good at high heat. But they don't do high heat and cold really fast because, like a dinner plate, it'll shatter.
Different temperatures.
Exactly. Yeah. That's standard ceramic aerogels. But this new layer is made from thin layers of boron nitride, which is a ceramic, with atoms that are connected in hexagon patterns like chicken wire.
Interesting.
So it's super strong, and it's essentially it's able to withstand fracturing better than older aerogels.
I'd actually like to see if I can pull up a video of this.
Yeah, so they're saying they tested it between a negative 198 degrees Celsius and 900 degrees Celsius over a few seconds. So, and in another test, it lost 1% its mechanical strength after being stored for 1 week at 1400 degrees Celsius.
Yeah.
And it's basically, they're saying that chicken wire type architecture is the reason for its incredible strength. Yeah. That it's just so a regular pattern that it's not like other aerogels. Like Grayson has a picture up right now.
So it's boron nitride. So it has a picture of boron nitride aerogel. So it has a mass density of 0.6 milligrams per centimeter cubed. That's
a human hair.
That it's resting on 2 human hairs. That's how light this thing is. This is resting on 2 human. Wow, that it's mixed. It typically consists of a mixture of deformed boron nitride nanotubes and nanosheets. So different kind of structures of the material itself, but it has a density as low as 0.6 milligrams per centimeter cubed, with a specific surface area as high as 1,050 meters cubed per gram. So
it's incredible.
It has an immense surface area for its size due to it being an aerogel. So it has applications as an absorbent, a catalyst support, and a gas storage medium. I actually didn't know that you could use those as gas storage.
I didn't either. So the picture that we'll have the articles linked below. The picture for this article is actually the aerogel resting on what looks like the seed stems of a flower.
That is awesome.
Which is incredible how lightweight that is. And they're talking about the uses for this. So they're, obviously they're going to use it for insulation in spacecraft. They've been using aerogels for that for decades. Mm-hmm. But they're also talking about, if they could create this cheaply, you could use it in so many other facets of life that require something a little stronger. So, like in the automotive industry, they could be using it for insulation in cars, but also a catalyst. They're saying that if you were able to put it in a catalyst, that would be able to, that would be a good enough insulator for a catalyst. Mm-hmm. Or filtration, or thermal energy storage. All these they're saying all of that could be done with this.
Yeah, that kind of, what is it? Thermal energy storage in this type of plastic or ceramic material. I don't know if we we already covered the whole Starlight thing, which kind of brings me back to that a little bit. I don't know. I just find plastics and ceramics, those two worlds, just amazing. Just in how
they're just so futuristic, really.
Well, yeah. I mean, what did people think of Kevlar when it first came out? You could stop bullets with it, and it's just a chain of just like a carbon chain of what is it? It's like hydrogen bonded carbon chains, isn't it?
Yeah, it pretty much is, and it's just so strong. Like they use it for so much in life now that it's a normality. Really, it's still incredible for what it is, but it's incredible for how much we use it for.
Well, yeah, it only came out in the late 1965.
But if you think about it, technology-wise, it's decades away. Think of how far back in technology we were in *65.
True. I mean, we barely got started with trying to expand the fuel efficiency of cars, even.
Yeah, and we had we had just had the space age. We were in the middle of the space age, but we had just had moon landings then.
Yes, we just got started. We just got done with the space race, pretty mm-hmm. much.
Yeah, we had won the space race right at that point, pretty much.
That's pretty cool. Wow. Yeah, I just find both of those worlds very fascinating. Well, I mean, that and ceramics and metals and plastics, just just because the applications for all those are massive in terms of because it's pretty much
just what they can do.
Because you can pretty much use them in almost every single industry, from medical applications to industrial applications to security applications to pretty much everything. I mean, with metals, I'm mostly interested in semiconductors, with how we can improve storage space for digital mediums. But
and like I think that's a little while away to find proper replacements for outdated technology. So like things like inductors and such, and like just everything in circuits, I think can still go smaller. We just have to find the right materials to work with it.
Well, like remember, okay, so one of our professors in our circuits class was talking about how inductors kind of they're the basically the bane of circuit design, because they're big, they're bulky, and they're not good at power dissipation. They're big, they're expensive. Yeah, I kind of was thinking, like, is there a way that we can use something like what was it? Like ferrofluid or some derivation of a solidified ferrofluid that's electrically active to produce a magnetic field in such a way that it acts like an inductor. Like, I think the best way for us to do that would be to, instead of using, we have to shrink it down, obviously, but we have to find a way to make a material that's electrically active as well as magnetically active.
Agreed.
That's
the trick.
Chemically homogeneous in such a way that it can be solidified to be used in electronics. Like, I don't know. I'm actually kind of curious to see if there's any material out there that exists like that.
And if you guys know of a material that exists like that, leave it down below in the comments. I mean, that would be an amazing thing to know about. That we don't know everything, and we'd love to know more. So, like, if there is a material like that, imagine the actual technology, like the industry as a whole, how much they could do with smaller inductors.
Yeah, because what is it? Like, I think the average size of an inductor right now is like 0.5 centimeters squared, whereas a lot of the other they're in millimeters.
They're smaller than millimeters.
Smaller than millimeters even. Yeah, that's if we can shrink down, because if we can shrink down inductors to that size and use them in that size, that would decomplicate or uncomplicate, I guess is the better word for it, a lot of circuit design in terms of how much area we could use. We could shrink down circuit boards to probably like a third the size if they use inductors.
Agreed. And like, here's the thing: we're not material scientists, so we won't ever be leading this kind of thing. But we just find it so fascinating that we hope that someone else sees the benefit of smaller parts for circuits, that hopefully one day soon we will be seeing smaller and smaller circuits, which has so many implications. You put that in a phone, something that's half the size, you just added more space for a battery or a better camera or better biometrics. Like, there's so many opportunities here if we can find the right materials. That's why I think material engineering is one of the most important types of engineering, and it's one of the most underappreciated at times.
Yeah, no, that's definitely insane. With what this came out on Valentine's Day. I think that little flower image is kind of, I guess that's kind of needed.
Yeah, it's like definitely interesting. But I think that this is just something to keep an eye on, and it's something we'll have to watch out for as the time goes on. But I think that we'll wrap it up here. I think that's enough for this week. As always, I'm Josh.
This is Grayson.
And thank you for listening. And we'll leave all of our links down below for our social. We have our Facebook down there, our Twitter, our Patreon. Feel free to support us on Patreon. We are looking, to upgrade our setup a little bit, see what we can do to better ourselves. And we always take input as we can get. And also, we'll link the articles down below, so you guys can read through them, tell us your thoughts, see if you find any fallacies in our logic. We always love to know when we're wrong, honestly, because that helps people grow.
Yeah, well, we'll see you all next time. Stay creative.
And thank you for listening to Delta Y.